learners. Welcome to this afternoon's mathematical literacy lesson. My name is Nikki Wezulu and I'm going to be your teacher this afternoon. Guys, this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center, and the broadcast is brought to you by the Pagama Research and Development. Girls and boys, today's topic is going to be on maps, plans, and other representations of the physical world with a specific focus on scale. This is a very exciting section on mathematical literacy. It's my favorite topic. I hope you guys are going to enjoy it and have as much fun on the certain topic that you guys are going to find on your paper too. Now, by the end of this lesson, guys, we should be able to differentiate between a number and a bar scale. Remember, in MathSlit, we're working with two scales, which is a number and a bar scale. You should also be able to express your number scale as a bar scale, and at the same time, be able to express your bar scale as a number scale. You should also be able to determine the scale used to resize the image. Sometimes you'll get an image and you will be required to determine the scale that was used, and you are going to do that with the assistance of your ruler. You should use the given scale to do calculations, whereby you are given either a bar or a number scale, and then you are required to perform certain calculations. You should be able to calculate the actual length of the drawing or the image of an object. And lastly, by the end of today's session, you should be able to discuss the disadvantages and the advantages of using either a bar or a number scale. Now, like all the other sections in MathSlit, before we do the actual calculations, we must first all be familiar with the terminology. I've been saying scale, 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 scale. Some of you are sitting there wondering, what is ma'am talking about? What is a scale? A scale determines how many times smaller an object shown on a plan or the map than it is in its actual size. So it's basically about the resizing of the object. A practical example when we're working with the scale, most of you are watching me from your smartboards. Others are watching me from your cell phones. So you can actually see my whole self on your cell phone, as small as your cell phone is. Does that mean that I'm actually that small in reality? No. In real life, I'm huge. I'm big. If you could see me, I am big. I'm way bigger than that smartphone. I'm way bigger than that board, the smart board. So this is where the concept of scale comes in, to say that it means my image, it has been resized, it has been reduced to be able to fit onto a smart board, to be able to fit into your cell phone. So that is the concept of scale when it comes to resizing, meaning that the object has been reduced. Another example of objects being reduced working with scale is if you have a map of South Africa. Normally, your map of South Africa, you're able to fit it on an A4 size paper. Does that mean that South Africa as a country, it is actually that small that it can fit onto an A4 paper size? No. It means this map, the South Africa as a country, it has been resized, it has been reduced by a certain scale factor so that it is able to fit onto a piece of paper. If you want to take a picture of your school, I'm sure you've seen the pictures of your school when you go into the office, the admin block. That is just a picture, an image of the school. It doesn't mean that your school as a whole, it is actually that small. That is where, again, the concept of scale is applied, that the whole building of a school, it has been reduced by a certain scale factor for it to be able to fit onto a small picture frame. Now, that is an example whereby a scale factor has been used to reduce objects. Sometimes the scale factor can be used to enlarge objects. And in the practical example that I can think about, it is your billboard. I'm sure most of us have seen a billboard once or twice in our lifetime. A billboard is that big board that they use to advertise. You see it when you're traveling on the road. Let me say they are advertising a calculator. With this calculator, it's so small that it can fit into my hands. But when it is on the billboard, it becomes so huge that we can even see it coming from a far distance. Does that mean that a calculator in real life is that huge? No. It means, again, the concept of scale has been used to enlarge this calculator by a certain scale factor. And then my learners that are doing life sciences, I'm sure you guys are also thinking about those tiny molecules that you guys normally work with in the life sciences when you are using your microscopes. There are some of the particles that are so tiny you can't even see them with your naked eyes. But when you use your microscope, you are able to see them bigger. You view them bigger. It means they are now becoming enlarged. So guys, that is basically what the scale is. When an image or an object has been resized. And resizing does not only mean to reduce, but it can also mean that the object is also enlarged. And it is enlarged by a certain scale factor. When you talk about a scale drawing, it is a diagram of a real object drawn in proportion. Take a practical example of my picture. That image of mine that you are seeing right now on the screen, that is not my actual size. That is my what? That is my scale drawing or my scale picture. And then, since we are talking about scale, we've got two types of scales, like I mentioned. We've got a bar scale and a number scale. So how would you describe a bar scale? A bar scale, it is presented as a picture. It means that if you placed a ruler next to the scale, you could determine how many centimeters represent the specified number of kilometers on that particular bar scale. And then a number scale, it is a number. It's a number scale. It is also known as a ratio scale. So don't panic there and say, I've never seen a number scale. Number scale, ratio scale, same WhatsApp group. So a number scale, how would you identify it? For example, it's written as a ratio. Like this practical example that I used here, 1:50,000. So how would you explain this scale? You will say that 1 unit on the map represents 50,000 units in real life or 50,000 units in reality. Now, girls and boys, it's very, very important that you know how to explain scale, be it a bar scale or a number scale, because I can promise you there is no math-lit question paper that you are going to write and they don't ask you to give the meaning of a particular scale, be it a bar scale or a number scale. On the 6th of June, you guys will be sitting for your paper 2 June exam. So you must expect this question where they ask you to explain the meaning of the scale. So when you come across that question, it mustn't find you confused. You must be ready to tackle it. You need to just get your 2 marks. This question is normally for 2 marks, just explaining the meaning of a scale. Now, guys, like I said that in Mathlit, we have 2 scales only. Don't be confused. I know in geography you might have more, but for our subject, we only focus on 2 scales. The first one, it is a number scale. And then I'm using this example again, 1:50,000. If you have to explain this, I wish you guys can just have this in your head. It must be a song that it is 1 unit on the map represents 50,000 units in reality. Sometimes you are in the exam, you even forgot the word unit. What can I say? You can use centimeters. You say 1 centimeter on the map represents what? 50,000 centimeters on the ground. The most important thing when working with the number scale is that the units must always be the same. If you use centimeters here, you must also use centimeters on the other side. If you decide to use kilometers, which is very unrealistic because you can't measure a kilometer on a piece of paper, but it's fine. It's fine, we'll forgive you. If you want to use kilometers here, you must also use kilometers this side. If you're going to use millimeters, even this side you must use what? You must use millimeters. The most important thing is that units must be the same when you are working with the number scale, when you are explaining it. So I'm going to repeat this again. How do we explain a number scale? For this particular example, we are going to say 1 centimeter on the map or on the plan represents 50,000 centimeters on the ground, or 50,000 centimeters in reality. Or 1 unit on the map represents 50,000 units in reality. That is how you explain your number scale. And then a bar scale. Remember when I explained the bar scale, I said a bar scale, it's like a picture. As you can see here, this is a bar scale. It is like a picture, and it is divided into sections, or rather into bars, hence the word bar scale. So what you need to know for this bar scale, the unit there, the distance from here at the start, it is 0, and then at the end there, it is 500 kilometers. Guys, 500 kilometers is such a long distance. Maybe it's the distance from Johannesburg to Pietermaritzburg in KZN, or from Johannesburg probably maybe up to Durban. That is how huge 500 kilometers is. So when they say this bar scale from here to there is 500 kilometers, this cannot be distance on the paper. This is the actual distance. If you want to know the distance on the paper, you are going to need to use your ruler. Use your ruler, and then you will measure the bar scale, and then it will tell you how long the bar scale is on the paper. But the only thing that we know is that in reality, this bar scale is actually 500 kilometers long. And then if you wanted to know how many kilometers does each division represent, remember from here at 0 up to there, it is 500 kilometers. But how many sections are there? This bar is divided into how many sections? 1, 2, 3, 4, 5. So if you wanted to know what is the size of one bar, you will take the 500 kilometers and then you will divide it by a 5. Remember, where is this 5 coming from? From the 5 bars that are represented there. So it is 500 kilometers divided by 5. It gives you what? It gives you 100 kilometers. So to answer this question, one bar here represents 100 kilometers. And since it's 5 bars, it's 100 kilometer, 200, 300, 400, up to 500 kilometers. Guys, I don't want to be talking alone. Remember, we have our active WhatsApp line number, which is 082 760 2630. So you can send in your messages. Remember, when you send in your message, always mention your name and the name of your school. So you send us messages, only text, guys, or if you want to send a picture, you can also send a picture. Just don't call us, guys. No video calling, no voice calls. Send us messages. If you want to ask anything that is related to the section of scale, you can send through a message. Or even if you don't have a question, if you just want to comment to say you are having fun, you are enjoying the lesson, you can also send that. You can send compliments. You can send a special shout out to your classmates or even to your subject teacher. And I will make sure that I recognize you guys and then I send out the special shout out. Now, guys, yes, the number scale, like I said, that the number scale, it is also known as a ratio scale. And it is called a ratio scale because it is written as a ratio. Remember the section of ratio you did in grade 10. So it is written as a ratio like this. And then remember, how would you explain this now? When you explain it, you are going to say 1 unit on the map represents 5,000 units in reality. If you want to use centimeters, you will say 1 centimeter on the map represents 5,000 centimeters in reality. You use meters, it's okay. You use kilometers, it's okay. As long as your units are the same. As long as the units are the same, then we are good to go. So guys, when I was explaining the meaning of scale, I said that picture that you see on your cell phone, that is not my actual size. In reality, I'm big. So what you see on the paper, it is my image that has been reduced by a certain scale factor. When I'm talking about the scale factor, what am I referring to? Here, in this 1:5,000, this 5,000 of ours here, this is our scale factor. And since it is 1:5,000, it means the image here, it has been reduced. And it's been reduced by what? It has been reduced by 5,000 units. We don't know whether it's 5,000 centimeters, millimeters, kilometers, but it has been reduced by 5,000 units. So that is the meaning of what? Of the scale factor. So a scale factor can be used to reduce or to enlarge. And then, guys, When we're working with the number scale, like I said, that we need to make sure that the units are always the same. Even when we explain it, you explain it in a way that the units are the same. And then the other thing that you must know is that the units should always be in their simplest form. So when you work with your scale, it must always be in the unit form. The unit form in a way that it is simplified to an extent that it cannot be simplified any further. And then always leave it as 1 is to something or something is to 1. That is the unit form that we are talking about. If, for an example, you are given a scale or you are doing calculations and then your scale is 5 is to 20,000. Let me write it here. This 5 is to 20,000. This scale must still be simplified and it must be written to its unit form. So how do we simplify this? The lowest common factor here is what is 5. So you are looking at a number that can go into 5, and then when you get the answer must be 1. So the only number that I can think of right now is 5. You divide by 5 this side, you divide by 5 on the other side. So that 5 and 5, they can cancel. You are left with 1 is to 5 goes into 20, guys. How many times? 4 times. So it is 5 into 4,000. 1 is to 4,000. So now this scale vector in its unit form, in its simplified form, it is 1 is to 4,000. And then with this simplification, we are lucky, we are happy, it is whole numbers. Sometimes, guys, your scale will be a decimal. It is okay. It is okay. It is not wrong. It is not unacceptable. Unless if the examiner instructs you that you must find the scale to the nearest whole number or to the nearest 1,000, to the nearest 100, to the nearest 1,000, then you know that you must have a whole number of a scale. But if there is no instruction and you end up with a decimal answer, it is absolutely acceptable. Girls and boys, remember to keep those messages coming. I'm waiting. It's very quiet this side. We haven't received any communication from you guys. I hope you guys are with us and you are enjoying this session as much as I'm enjoying. Remember, I told you that this is my favorite part. This is my favorite section in the entire mathematical literacy. I'm hoping to transfer the same energy to you guys. Now, guys, the practical examples. The measurement on a map is 15 centimeters. And the scale of the map is 1 is to 30,000. So guys, when you are in the exam, like for this example, I already did the measurement for you. So it means there was a particular map and then I measured the points from point A to point B using a ruler. And then I got what? I got 15 centimeters. Now, the scale of the map is 1 is to 30,000. So we must calculate the actual measurement in kilometers. The other thing that I forgot to mention, guys, is that when you are working with the scale, let's say you've got 1 is to 5,000. The first value here, it will always represent the distance on the map. And then the second value will represent what? The actual distance. Always. It doesn't matter. Even this one here on this side, even if it was bigger, the fact that is the first one, it will always represent the map distance or the distance on the picture or the distance on the paper. Whereas this one, the second one, will always represent the actual distance. And again, it's not always going to be bigger, this one. Sometimes it will be smaller to show that an object has been enlarged. So, but this one will always represent the actual distance. So now we've got our scale here. Our scale is 1 is to 30. Remember, I said the first one will always represent what? The map distance, and then this one will always represent what? The actual distance. So the measurement on the map, we have it. It is what? It is 15 centimeters. So since this side is for the map measurement, we'll write our 15 centimeters here. And then we want the actual distance. Calculate the actual measurement in kilometers. So I want the actual distance. I will just say actual. So how do I go about this one? You can use whatever method you feel comfortable with. For me, cross multiplication works for me. So I'm going to say 1 multiplied by the actual. Remember, anything multiplied by 1, it is that item, whatever. If you say dog times 1 is dog, girl times 1 is girl, Actual times 1 is actual. So actual equals to, and then we say 15 multiplied by 30,000. This is the point where you take out your calculators, guys. You say 15 multiplied by 30,000. What is the answer? It is 450,000. So the answer is 450,000. But remember, you multiplied by what? By centimeters. So it means the answer is going to be what is going to be in centimeters. But what was the question? The question, they wanted the answer in kilometers. Guys, how do we convert from centimeters to kilometers? King Henry died miserable death called measles. Let me write it here for you. King Henry died miserable death called measles. And then in between is a 10, is a 10, is a 10, 10, 10, 10. And you know when you're converting from a larger unit to a smaller one, what do? You divide. From a smaller, you multiply. From a smaller unit to a larger one, what do? You divide. I'm not going to waste time on this. Remember, you did this last week when you guys were doing conversions with one of my colleagues. You guys did King Henry. So I'm not going to entertain it any further. So now we are converting from centimeters to what? To kilometers. From centimeter to kilometers. You are moving backwards, meaning that you are going to divide. It's 1. And how many zeros? 1, 2, 3, 4, 5. So it's 1 with 1, 2, 3, 4, 5. Meaning the conversion factor between centimeters and kilometers is 100,000. And then we are dividing because we are converting from a smaller unit to a larger unit. So 450,000 divided by 100,000. Guys, if you are not sure, you always use your calculator. No one will penalize you because you are using your calculator. And the answer is 4,5 kilometers. That is your actual distance in kilometers. And then B, the scale of a map is given as 1:500,000. If you are in the exam, I want you to write already that, okay, it means the 1 is the map, and then the 500 is what it is then? The actual. So that is the scale that is given to us. What is the distance in meters on the ground? On the ground means what? The actual distance. On the ground is where I'm standing here. It is the actual distance. If the measurement on the map is 60 millimeters, so the measurement on the map is already been given. So again, we will say 1:500. Remember, this is map is to what? Is to actual. So we have the map distance there is given to us. What is the map distance? It is 60 millimeters. We want the actual distance now. We'll make this what? We'll make this actual. So we cross multiply. 1 multiplied by actual. It is actual equals to 60 multiplied by 500. You take your calculator. You say 60 multiplied by 500. The answer is 30,000. 30,000. But you multiplied with what? With millimeters. Meaning your answer is going to be 30,000 millimeters. Are we done? No. The instruction wanted us to calculate the distance in what? In meters. You go back to your King Henry. You know that from millimeters to meters, you are going back. And since we are going back, it means we are going to divide. And what is the conversion factor in between? It's 1, 2, 3. Meaning the conversion factor is 1,000. 1 and 3 zeros. So 3,000 divided by 1,000, it is 30 what? 30 meters. So this is the actual distance in meters. And then a bar scale. Before I touch on a bar scale, guys, we like hearing from you guys. Covered the section of number scale, the examples of a number scale. If you have any questions, if I left you somewhere, if you lost me somewhere, please send us a message, a WhatsApp message on 082-760-2630. We'd like to hear from you guys. Even if you don't have a question, you can just send a comment, send a shout out to your classmates, to your teacher. Remember to mention your name and your school name. Or if you just want to compliment us to let us know that you are enjoying this lesson, you are more than welcome to do so. Now, our second type of a scale is a bar scale. And then a bar scale is also called a graphic scale or a linear scale. So any of those three names. If your teacher is using a linear scale, correct. If they are using a graphic scale, 100%. Again, the most popular one, it is a bar scale. It is a bar scale because bars of a certain length are used to show the scale on a map. Like this one again, it's our bar scale because it is divided into certain bars, or it is divided into sections. And then each piece of the segment represents the given distance. From here up to there is 500, meaning how many bars are there? It's 1, 2, 3, 4, 5. So what does each how much does each bar represent here? It means each bar represents 100 kilometers. So it's 100 kilometer, 200, 300, 400, up to 500 kilometers. So each piece of the segment represents the given distance, like I've explained. So when you work with a bar scale, guys, you will always need a ruler. You can never ever work with a bar scale without a ruler. So from here on, from today, when you go to your exam room, you need your calculator. You also need your ruler. Guys, a proper ruler, not a ruler that you share amongst yourselves and your friends, a proper ruler, a complete ruler, because you are definitely going to be asked to do some measurements in the exam. So if you don't have a ruler, you won't be able to answer those questions, and you can't even borrow a ruler from your friend. And when you're working with a bar scale, guys, remember I said with the number scale, the units must always be the same. But with the bar scale, we don't worry about the units. You'll see when you do calculations of a bar scale that we don't really care about a bar scale. Now, guys, if we were to explain the meaning of this scale, you are going to take this ruler, and then I'm going to use the section of centimeters, and then I place it here on the bar. When I place it here on the bar, I got what? I got 4 centimeters. So when you explain a bar scale, you basically explain what you have done. What did I just do now? I took my ruler, I measured the bar, and what did I measure? I measured 4 centimeters. What does that mean? It means 4 centimeters measured on the map represents what? 500 kilometers in reality. Done. You've explained your bar scale. So this is how you explain it. Again, 4 centimeters measured on paper or on the map represents 500 kilometers in reality. And this question is what is for 2 marks. This is how you explain the meaning of a bar scale. With the bar scale, we don't care about the units. The units don't have to be the same. You can see here we are talking about centimeters. Here we are talking about kilometers. This is how you explain a bar scale. Done. So here is a practical example, guys. I wanted to show you this so that I want to make sure that all of us know how to use a ruler. Hey, people, the things that we see when we are marking. Your sisters and brothers, when they have to measure, they start measuring at 1, others start measuring there from where the ruler starts. Guys, when you measure, you will always start measuring from this point from 0. Are we okay? You will always start measuring from 0. And then now let us analyze our ruler. We've got 0, 1, 2, 3, 4. These are millimeters, guys. So from 0 here, you've got 1, 2, 3, 4, 5. It means here it's actually 5 millimeters. And then you've got 6, 7, 8, 9. It means here this one is actually 10 millimeters. This is 15 millimeters. This is 20 millimeters, 30 millimeters, 40 millimeters. I hope you guys are with me. I hope you understand. Now, for this example, guys, we are going to convert a bar scale into a number scale. Remember, what are the properties of a number scale? 1, the units must always be the same for a number scale. If it's millimeters, must be millimeters everywhere. Centimeters everywhere. That is number 1 that we know about a number scale. And then secondly, it must always be in its unit form. To be 1 is to something. So when we convert this bar scale into a number scale, those are the items or the factors that we must consider. So step number 1, you measure. Step number 1, you measure. Did we do our measurements? Yes. How much did we measure on the paper using this ruler here? Up to this 4, it is what it is. We measured that 40 millimeters. It is actually equivalent to what, guys? To 1 kilometer. We've measured. And then step number 2, the units. Units must be the same. Are our units the same? Nope. We've got millimeters, we've got kilometers. So we need to make our units to be the same. And then, guys, it's advisable to always convert your larger unit into a smaller unit. So my smaller unit is millimeters, but my larger unit is what? It is 1 kilometer. So using the King Henry, how do we convert kilometers to millimeters? We know that because it's a larger unit, we are going to multiply. And what is the conversion factor between kilometers and millimeters? It is a million. 1, 2, 3, 4, 5, 6. And then we'll have 40 millimeters is to 1. Anything multiplied by 1, remember, is that same thing. 1 million millimeters. The units are the same now. We are happy. With ratios, when units are the same, they cancel. So the second step, it is the unit. And then step number 3, we must simplify. Leave it in its unit form. For unit form, remember I said it is 1 is to something. So we are going to take this 40 is to 1 million. How do I turn this 40 into a 1? You are right. We are going to divide by 40. And what we do on this side, we also do on the other side. Then 40 and 40, they cancel. We are therefore left with 1 is to, guys, please assist me that side. It is 1 million divided by 40. And then I'm getting the answer of 25,000. So it means now when we convert this bar scale into a number scale, it is equivalent to 1 is to 25,000. Girls and boys, this is how you convert a bar scale to a number scale. This is examinable. You can come across something like this in the exam. Make sure that you practice it, you understand it. It's just these 3 simple steps. Step number 1, you measure your bar scale. We measured our bar scale, and then we realize that 1 kilometer on the bar scale here represents what? It represents 40 millimeters. And then step number 2, we wanted to change the units. So we've got 40 millimeter is to 1 kilometer. So how do we convert kilometers to millimeters? We multiply by a million. So 1 multiplied by a million, it gave us 1 million millimeters. The units were the same. We are happy. We move on to step number 3. Step number 3 says we must do what? We must simplify. And how do we simplify? We looked at the number that it goes into 40, and the answer will be 1. And there's only one number, which is what it is? 40. To say 40 divided by 40, we get 1. And then 1 million divided by 40, it is 25,000. So the answer is 1 is to 25,000. And then, guys, here is another example of a bar scale. So we've got our bar scale. It has 1, 2, 3, 4, 5 bars. And then the entire bar scale is equivalent to what? 200 kilometers. How many kilometers does each division represent? So we've got the total is 100 kilometers. And then how many bars are there? It is 5 bars. So 100 divided by 5, it is equals to what it is? 20 kilometers. So the answer here, it means 1 bar actually represents what? 20 kilometers. Now, we need to convert the bar scale above to number scale of the map. If the total measured length on the bar scale is 10 centimeters. So guys, we are going to convert a bar scale to what? To a number scale. Now, I want to give you guys a chance to try this one on your own. I'm giving you only 2 minutes. Try this one. I've already done the measurement for you. I've measured the bar. and I measured it to be 10 centimeters. It means 10 centimeters is equivalent to 100 kilometers. 2 minutes, guys. Try it out and send through the answers. I will shout out your answers. Welcome back, guys. I hope you are sending those messages. Unfortunately, our system is a bit slow, but as soon as I get those messages, I'll make sure that I read them out loud for you. Now, let us do it together. Then you can check if you are on the right path or not. So I said I measured this bar using my ruler. And when I measured it, I got 40 centimeters. So how do you write it down? Then you say 10 centimeters that is measured. It is equivalent to what? To 100 kilometers. Are we okay? That is step number 1. Remember, step number 1, it is the measurement. And because I'm a nice person, I did the measurement for you. Step number 2 is to make the units to be the same. We've got kilometers, we've got centimeters. Always, guys, this is an advice. It's not an instruction, it's an advice. Always try and convert your larger unit to a smaller unit. So from kilometers to centimeters, what do? We multiply. And we will multiply by how much? By 100,000. So then the answer would be 10 centimeters is 2, 1, 2, 3, 4, 5, which is 10 million. I hope I'm accurate. It's 10 million. And then the unit is now centimeters. The units are the same. We are happy. When the units are the same, automatically they cancel each other. Now we are left with 10 is 2. Remember, we want our scale to be in the unit form. Unit form, it means we want it to be 1 is to something. So to get rid of this 10 and make it a 1, we must divide by 10. What we do that side, we must also do on the other side. So 10 divided by 10, what do we get? We have 1 is 2. And then 10 million divided by 10, our answer is still, it's going to be 1 million. 4, 5, 6, let me see, 1, 2, 3, yes. So it means now our scale, this bar scale, when you convert it to a number scale, it's actually 1 is to a million. Guys, that's it. That is how you convert a bar scale to a number scale. It can be asked in the exam. And then see how many kilometers does 40 centimeters on the bar scale represent on the ground. So this means that if you measured the bar and then it measured 40, so I'm sorry, we said when we measured this bar, when we measured this bar, it actually measured, guys, 10 centimeters. I'm sorry, I made a mistake. I said it measures 40 centimeters. It was supposed to be actually 10 centimeters, but it's okay. No, but I wrote here 10 centimeters, so it means I can just correct this one. That 10 centimeters represents what? It represents 100 kilometers. I'm sorry about that confusion. It is 10 centimeters. So when you measure this bar from here up to there, you got 10 centimeters. So the next question says, how many kilometers does 40 centimeter on the bar represent? Remember, on this bar, 10 centimeter, it represented how many kilometers? 100 kilometers. Now they are asking if you have 40 centimeters. 40 centimeters, it would actually represent how many kilometers? Remember, in a 40, how many tens do you have? You have 10, 10. You have 4 tens. It's 10, 20, 30, 40. So it means in 40 centimeters, how many hundreds do you have? You have 400. So it means 40 centimeters will therefore represent what? 400 kilometers. That's just it. Or if you want to do a calculation, you can use the cross multiplication to say that, okay, 10 centimeter represents 100 kilometers. Now the 40 centimeters, it represents what? You can make a question mark and then cross multiply. Your answer is going to be 40 centimeters multiplied by 100 kilometers divided by what? By 10 centimeters. Centimeters and centimeters, they cancel. We say 40 multiplied by 100 is equals to 4,000. 4,000 divided by 10, the answer is 400. And it is 400 what? 400 kilometers. So you can do it both ways. You can use the first short, straightforward method, or you can use this long calculation. It doesn't matter. At the end of the day, we are all getting into that destination. Now, guys, as much as we are now familiar with the calculations that are involving a bar and a number scale, sometimes when the scale that we are using, let's say the map or a picture that you are working with, it is not the original image. It not being the original image, it could mean that more photocopies were done, and as we're making more photocopies, then the item, the picture or the map, it got resized. By resizing, it means it could have become now bigger than the original size, or it could have become smaller than the original size. And there are some of the scales whereby if an object has now been resized, been made bigger or smaller, then that particular scale becomes inaccurate. Like whatever you are going to do, it is not a true reflection. It is not accurate because the scale now is affected. And that particular scale, it is a number scale. So if a picture is resized, made bigger or smaller than its actual size, your number scale becomes inaccurate. It becomes inaccurate. You cannot now work with your number scale. And this makes it a disadvantage of working with the number scale. It is a disadvantage because now when you resize the map or your plan, the ratio or the number scale becomes inaccurate. You can't work with it. But as much as it is a disadvantage, it also has an advantage. So the advantage is that number scale is more convenient to use when you are working with small scales, like your 1:20, 1:5, 1:10. It's very accurate. With a bar scale, it is the opposite form of number scale. With a bar scale, whether an image has been enlarged or reduced, the bar scale will still remain accurate. If a picture is enlarged by a factor of 10, the bar scale will also get enlarged by a factor of 10. If a picture is reduced by a factor of 500, the bar scale will also get reduced by a factor of 500. So a bar scale will never be affected by the resizing of of the object or the image or the map. And that is an advantage of working with a bar scale, is that resizing the map or plan will not affect your bar scale at all. And then it also has a disadvantage. The disadvantage is that you need to measure the length of one segment before you can be able to start with your calculations. Basically, if you don't have a ruler in the exam, you will not be able to work with a bar scale. It's going to be very difficult. It's going to be a challenge for you to do any calculations that have to do with the bar scale if you don't have your ruler. Now, girls and boys, those are the advantages and the disadvantages of working with a number scale and a bar scale. So when we're working with scale calculations, guys, these are the 3 type of questions that you can expect in the exam as you guys are preparing now for your June exam, that using the given scale and the map measurement to determine the actual distance. You will definitely be required to calculate the actual distance, either using a map or using whatever image that is given to you. You must also expect to use the given scale and the actual distance to determine the measurement on the map. Guys, sometimes you'll be given the actual distance and then you'll be given a scale. And then from that information, the examiner can ask you to calculate, to determine the distance on the map. So you can do that 2 ways. You can do that for calculations, or you can make use of your ruler to find the distance on the map. You will also be required to use the measurement on the map and the actual distance to determine the scale of the map. Sometimes you're going to be given an image, a picture of myself. There is a picture of Nigiwe. Determine the scale that was used on this picture. So you must know where to start. And then again, you will always need your gun. What is your gun in this case? It is your ruler. So here is an exam type of a question. And we've got a television, as you can see, and it has the dimensions. So we also have a scale. The scale is 2000:1. This one is a bit different. You are not used to it. You guys are actually used to 1:2000. So in this case, it's like the numbers have been swapped. And it's not a mistake, guys. That's exactly how it is. So you need to explain the meaning of the following ratio scale. Remember what I said? I said this one, the first one, will always represent the map. Whether it's big or small, the first one will always represent the map. And then the second one will represent what? The actual. Why is the map bigger than the actual? It means now this object has been enlarged. Remember the billboard example that I used with the calculator? The object has been enlarged. So how do we now explain this? We explain this by saying that 2000 units on the map represents 1 unit in reality. You explain it the same way that we explain all the other scales. So this 2000 units on the map represents 1 unit in reality. If you want to use centimeters, you will say 2000 centimeters on the map represents 1 centimeter in reality. That is how you explain your scale. Now, Lihle bought a flat screen TV, as we have seen on the picture here. And then the dimensions are also indicated on the TV. Use the length distance. Guys, remember, when you do your measurements, the length is always the longer side. So in this case, this is our length from that point to the other. So here, this is our length. They say use the length distance to determine the scale that is used on this drawing if the measured length is 80 millimeters. And write the scale in simplified form. Remember, I said sometimes you'll be given an object and you will be required to determine the scale. So the examiner here was very nice. They actually measured. They took a ruler and measured the length of the TV. When I measure here, I am getting 80 millimeters from one point. I'm measuring, guys, from here, from the point here up to there. So I'm getting 80 millimeters. So I'm writing down what I got. It is 80 millimeters, which is the same as this one. It's equivalent to what? It's equivalent to 947 millimeters. We want a scale. And then with the first step, we've done our measurement. The second step is to make sure that the units are the same. Are the units the same? Yes, we are very happy our units are the same. And when units are the same, automatically with ratios, they cancel each other. So units are the same, we are happy. We now have 18 is to 947. So the next step now is to write our scale in unit form. How do we write in unit form? We are going to divide here by 80, divide the side by 80. What you do on one side, you must also do on the other side. So 80 and 80, they cancel. We've got our unit form is 1:2. Let me quickly use my calculator. Guys, the way I'm relying on my calculator, it's not even funny. I hope you guys have the same relationship with your calculators. It's 947 divided by 80, which is 11,8375. Guys, our scale is a decimal, and there is absolutely nothing wrong with that. There is nothing wrong. There was no instruction that we must round off our scale. There was nothing. So if it's a decimal, it's fine. It is still correct. If maybe they had said round it off to your nearest whole number, then our scale would be 1:12. Done. But now because they didn't do anything, this is still okay. This is still acceptable. Remember, guys, to keep those messages coming, though we are struggling with network this side, but as soon as everything is fixed and sorted, I will be able to see your messages and I will read them out. So, guys, yes, do send out those shout-outs. And remember to mention your name and the name of your school. So the second question now, colleagues, girls and boys, I'm sorry. We must study the school map that is given alongside and answer the questions that follow. So here is the school, or the map of your school, guys. You have your school hall here, the sports field, maths class, science class, the tuck shop. There is a tree to chill at break, and then there is the bathrooms. So this map of the school, it has a scale. The scale is 1:500. So the question is, explain the meaning of 1:500. Guys, how do you explain the meaning of a scale? We say 1 unit on the map represents 500 units in reality. This is how you explain your scale. That's it. And remember, I said sometimes you're going to forget this word unit. You can even say 1 centimeter on the map represents 500 centimeters in reality. You will still get your full marks. This question is normally for 2 marks in the exam, 2 marks in the back, just like that. And then still on the same map of your school, we must use the given scale, the 1:500, to calculate the length of the sports field in meters if the measured length is 10 centimeters. So sometimes, guys, you will not be given the measured length. If you're not given the measured length, you take your ruler and then you place it. I'm placing it on the length. The length, remember, is the longer side of the sports field. So this one, they've already done it for us. So they said the measured length. This one is the length on paper. Let me write it on the map is to actual. The measured length on the map, it is 10 centimeters. Is true. We want the length of what of the, use the given scale. I'm sorry. So the scale is 1:500. And then the measured length on the map, it is what? It is 10 centimeters. So what do we want? We want the actual dimensions. So how do we now determine the actual dimensions? It is 1 times actual. We get the actual. And then we've got 10 times 500. You use your calculator. You say 10 times 500. The answer is 5,000. But remember, guys, you multiply it with centimeters here. So the answer is actually 5,000 centimeters. But what was the question? The question is that you must calculate the length of the sports field in what? In meters. So how do we convert from centimeters to meters? Remember the King Henry. Between centimeters and meters, what is the unit there? The conversion factor, it is 100. And then here you are converting from a smaller unit to a larger unit. Therefore, you are going to do what? You are going to divide. Divide by 100. So the answer that we are getting would be what? Would be 50 meters. So the actual length of the sports field would be equals to what? It is equals to 50 meters. And then Zuki walks from the tuck shop to his maths class. Guys, remember this is the tuck shop and then this is the maths class. So it means she's along the broken line that is shown. So she'll be walking along this broken line. I'm sure we can all see the line there. You must measure how far he walked in meters if the broken line is centimeters. Guys, for this one, we can't measure meters on a piece of paper. So we will have to do what? We will have to calculate. We must calculate how far he walked in meters if the broken line is centimeter. So the broken line has been measured with a ruler and then gives what? 6 centimeters. Again, we are going to use the scale. 1:500. The measured line is what? It is 6 centimeters. And then we want the actual. So let's cross multiply. The actual is equals to, and then 6 multiplied by 500. 6 times 500 is equals to 3,000. Remember, guys, you multiplied by centimeters. So your answer will be 3,000 centimeters. What was the instruction? How far did he walk in meters? So we need to convert the centimeters to what? To meters. And then we know from King Henry that when we convert from centimeters to meters, we are going to divide. And then we are going to divide by how much? By 100. So the actual distance would be 30 meters. That is the actual length that this person walked from the tuck shop to the maths class. Now, guys, we have a street map then. I know it's not very clear, but the most interesting thing about the street map then, it is the scale that we are having there. That is the only thing that we are talking about today. So we are going to use the street map alongside to answer the questions that follow. 1, you must identify the type of scale that is used on a map. I circled my scale, guys, here. And what type of a scale this one? It's definitely not a number scale. It is not a ratio scale. However, it is what? It is a bar scale. You should expect such questions in the exam, guys, especially on question 1. So this type of a scale is it's a bar scale. And then B, you are going to use the scale of the map to determine the actual distance to the nearest kilometer between the police station and the agricultural station if the measured distance is 26 millimeters. So we have a measured distance from one point to the other. It is from the police station. I'm looking for the police station on the map. And there is the police station, guys. The distance from to the agricultural station. I'm looking for the agricultural statue. I can't see. Okay, let's say it's here. This is the agricultural station. So the distance from this point to that point has been measured. And it is measured to be what? To be 26 millimeters. And then the bar scale is also being measured for you. The bar scale from here up to here, it is measured to be what? To be 90 millimeters. So you've got these two measurements, and then you need to calculate the actual distance to the nearest kilometer from this point to that point. Remember, the bar scale measured, it is what? It is 300 kilometers. So guys, I'm going to give you exactly 2 minutes to do this calculation and then send through your answers. We'll make it all together. 2 minutes. Welcome back, guys. I hope you got the answer and then you are sending them. I just checked the messages. I haven't received any solutions, but I have some exciting news. We do have some shout outs here. We have a special shout out from the learners from Ruta Sechaba, that is in Sidibeng West. Thank you so much, guys, for tuning in. There's also a special shout out from Tabiseng. Tabiseng is from Ikusasa. Hello, Tabiseng. I'm glad that you are with us and you are enjoying. And then lastly, there's also Sticks. Past Sticks, we are so happy to have you here from Kaltura. Guys, keep those shoutouts coming. But most importantly, I'd like to see your calculations, how you guys are doing this. You can just take a picture, a screenshot of your calculations and send it through our WhatsApp. And then I will read your correct answers live in this session. Now, let's continue. I said we have to calculate the actual distance from this point to that point. Remember our bus scale, guys, our bus scale is actually 300 kilometers. So our bus scale there, it is 300 kilometers. And then when it was measured with a ruler, it was measured to be 19 millimeters. So it is always the map is to the actual. And then the distance from one place to the other that is measured on the map, it is 26 millimeters. So what do we want now? We want the actual distance. So then how do we do this one? We cross multiply. Very easy. So it is 90 multiplied by the actual. It will be 19 actual. And then 26 multiplied by 300. Guys, I can never do this in my head, so I'm relying on my calculator. 26 multiplied by 300, it is 7,800. But we want the actual distance. So since we want the actual distance, we are going to divide here by 90, divide here by 90. So that the 90 and this 90, they can cancel. Therefore, the actual distance is equals to 7,800 divided by 90. The answer is what? It is 86,666. Guys, this side we had millimeters. The units were the same. Here we had kilometers. It means whatever that we are going to get here is going to be in kilometers. So our answer here, it is actually in kilometers. Are we done? No. The instruction was that the answer must be to the nearest kilometer. So if it is to the nearest kilometer, it means we must round our number to the nearest whole number. They want it as a whole number. So since it is 86,666, it automatically becomes 87 kilometers. That is the actual distance from the police station to the agricultural statue. I hope you guys have the same answer as the one that I got here. And then we have a map here. We have a national map alongside, and then we are going to use it to answer the questions that follow. So our map, it also has a scale. So since this map has a scale, you must identify the type of scale that was used on that map. What type of a scale is this, guys? You are correct, 100% correct, guys. It is a number scale. It is a number. Others are saying it is a ratio. So it is a number or ratio scale. And then you are done, you leave it there. And then you are going to use the given scale, this one 1:10 million, to determine the distance in kilometers between Hermanus and Johannesburg. Guys, where is Hermanus on the map? It's not that clear. It's not very clear. Here, there is Hermanus, there is Hermanus, and there is Johannesburg. So you must calculate the actual distance in kilometers between Hermanus and Johannesburg as the crow flies. What does it mean as the crow flies? As the crow flies means in a straight line direction, using a bird's view. It's like, you know, when a bird is flying, it's flying in a straight line. It doesn't say there are trees here, there are buildings. No, it just flies on top of that. So this is what is meant by the crow flies in a straight line. So it means from here on, as the crow flies is where you draw a line with your ruler. I'm using a ruler, guys. So that is where you draw a ruler. So if the distance on the map between these two cities measures 13 centimeters, so the distance from this place to that place, it is what? It is 13 centimeters. So we go back to our scale. We know our scale. It is always map is to what? Is to actual. Since its map is to actual, what is our scale now? It is 1. 1 is to what? Is to 10 million. And then what did we measure on the map? We measured 13 centimeters. So we want what? We want our actual distance. Are we good? I hope you guys are following. And then let's cross multiply. 1 multiplied by actual, it is your actual. 13 multiplied by 10 million, you will take your ruler and then you say 13 multiplied by 10. 1, 2, 3, 4, 5, 6. Make sure that you include all your zeros, guys. Don't make mistakes. It's 130 million. But remember, this is what? This is centimeters. And we are talking here distance from one city to the other. So the distance from one city to the other. And then they said they wanted it in what? In kilometers. So from centimeters to kilometers, the conversion factor there we are going to divide, and will then be divided by what? By 100,000. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our answer, the actual distance, therefore, the actual distance is equals to 1,300 kilometers. That is the estimated distance that you will travel if you're traveling from Johannesburg to Hermanus. Hermanus is in the Western Cape. Guys, I hope you understand. I am not confusing you any further. And remember to send through your questions if you have any question. If I lost you, even if I lost you in the first slide, if there's a statement that I said that you did not understand, please send a question. Send your concerns in our WhatsApp line number, which is 082 760 2630. We like hearing from you guys. And now, guys, like I said, that sometimes we'll be given a map like this one. There is no scale, no number scale, no bar scale. We just have a map. And what type of a map are we having here? This type of a map is actually a distance map. These numbers that you are seeing, this one, these are the route numbers. This is the name of the of the road. But you have these numbers here that have nothing. These are the distances. These are the distances. This is it's a distance. So even this one, the 6 is the distance, the 22, the 39 is a distance, the 60 is a distance. So all these numbers that are not covered, they are your distances. Are we okay? So it means the distance from Modderrivier to Speyfontein, it is what it is, 16 kilometers. And the distance from Heiningskloof to Ricci, it is what it is, 22 kilometers. The clearest distance for me here, it is from Edinburgh is this star, to Tromsø up to this star. The distance is what it is, 39 kilometers. And those are the actual distances. So I'm going to use these two places because of the stars and they are clear. So I will use the distance from Edinburgh to what? To Tromsø. The actual distance then, it is actually 39 kilometers. So for me to be able to determine the scale of this map, I need a map distance. I'm given the actual distance. Now I must get the map distance. How do I get the map distance now? The map distance, that is where your ruler comes in. That is where you use your ruler. Can either use your millimeters or your centimeters. And remember, when you measure, guys, you don't measure on the letters, you measure on the points. In this case, you measure from one star to the other star. So when I measure using my millimeters, I'm actually measuring 20 millimeters. So the map distance that I'm getting here, it is 20 millimeters. And remember, when you write our scale, it is always the map is to what? Is to actual. So how do we write it then? We'll say 20 millimeter is to what? Is to 39 kilometers. And then the number one rule when working with the number scale is that the units must be the same. So let's change this kilometers to millimeters. We multiply by a million. So we'll have 20 millimeters is to 39 multiplied by a million. It is what it is, 39 million millimeters. So the units are the same. And then what is the next step now? The next step is to simplify and leave it in unit form. So the units, because are the same, they cancel one another. So then we divide by 20, divide that side by 20. 20 and 20, they cancel. You've got 1 is to, let's do it, guys. 39 million. Oh, such a big number. 39 million divided by 20. The answer is 1,950,000. Such a big scale. So the scale that is used for this map, it is 1 is to 1,950,000. Guys, this is how you determine the scale of a map. You must have the actual distance, and then you can determine the distance on the map using your ruler. And then once you have those two values, you follow all the same procedures when you're working with the bar scale, that the units must be the same, and then you simplify your scale and leave it in unit format. Oh, okay. And then, guys, we are not done. I'm just going to take a quick 1-minute break, and then we'll just change our presentations. We'll move on to the next presentation. 1 minute, guys. I'll be back right now. Hi, guys. We have come to the end of our scale section. I hope you guys enjoyed that section. And now to all of you guys, including your teachers, if you understand scale thoroughly, if you make sure that you grasp the concept of scale, you know how to perform calculations that are involved in scale, you will see this next session that we are going to do of the maps and plans. It is going to be a smooth ride for you because scale, it is the basic of maps and plans. And once you know scale, I promise you, you are going to pass your maths lit. You are going to pass this section of maps, plans, and other other representations of the physical world. The same way, if you know your conversions, if you know your King Henry, you must know it by heart, guys. If you know your King Henry, you are going to be able to work with your scale. Once you know your scale, then maps and plans, a smooth ride. So if you don't know King Henry, guys, if you don't know what happened to King Henry, please make sure that you go and study. You must go and memorize that song because every question paper of Maths Lit paper 2, you will be expected to apply the King Henry. King Henry died miserable death called measles in grade 12. You are expected to know those conversions by heart, changing from one unit to the other. Now, our next section, guys, after scale, it is the section of maps. This is a beautiful map. I hope it's very clear on your screens as well. When we talk about a map, we are talking about the diagrammatic representation of an area of land or sea showing the physical features like your national provincial map, the strip chart, the elevation map, the street maps. All those are the different types of maps that we are going to be working with. And then a map can also be expressed as a plan, like your sitting plan, the way in which you guys are sitting in your class right now. That is a sitting plan. You will see again when you sit for your exams, whether it's your June, your prelim, or your final exams, you don't just sit wherever you want to sit. There's a certain plan that you guys must follow. If you go to a cinema, if you've been to a cinema, you will also know that at the cinema, you don't just decide and choose that I want to sit in the front, I want at the back. No, there's a certain sitting plan that must be followed. The last example of a sitting plan, guys, is a stadium. The people that have been to the stadium to watch soccer, again, be it soccer or a concert, you don't just choose for yourself where you want to sit. There's a certain sitting plan that must be adhered to. And then sometimes again, you'll find that the prices for the seats that you buy, they will not be the same. If maybe you're going to a concert, someone that wants to go and sit in the front to have a first-hand view of the performance, that person will obviously pay extra money. If you want to sit there at the back, far away from the show, you won't pay the same money that a person that is sitting in the front is going to pay. Guys, before we go into our maps, the most important thing that you must know, it is the compass directions. You are expected to know the compass direction. And then we have the 4 main directions, which is your north, your south, your east, and your west. You must know that by heart, guys, because sometimes in the exam, the examiner will just give you an arrow and say north. You must know that if this is north, where is your east, where is your south, where is your west. Now, I know that learners from Mutas Chaba, there is something that they are using that helps them to remember the compass direction. They say it is never, ever smoke weed. So with this, they'll never ever go wrong because they will always remember that if it's up there, it is north, it is south, it is east, and then it is your west. That is why you must never ever smoke weed. And it doesn't matter how the compass is given to you. Sometimes in the exam, the examiner will give you an arrow pointing like that and say this is north. You don't say it's a mistake, I'm gonna move my north. No, you work with that given north. The most important thing that you must know is that you must never ever smoke weed. So with that, you know wherever your south, your north is, you know how to complete it and put the other cardinal points. And then, guys, we also have 4 more directions in between them. So since this is north, this is east, it means in between here, we've got northeast, here we've got southeast, Here we've got southwest, and finally here we've got northwest. In Mathslit, girls and boys, we only work with these 8 cardinal points. Only. We work with your north, your east, your south, west, northeast, southeast, southwest, and the northwest. Please don't be confused. I know some of you are doing geography, and in geography you've got more. But in Mathslit, we only work with this 8. I hope we are all okay and we are all following. So we use the compass direction to find the location. So when we find the location, we use the directional indicators such as left, your right, your straight, your up, your down, and your 10 down, 10 right, and 10 left. And then, guys, sometimes the examiner can ask you to give the general direction. As soon as the question says give the general direction, you must know that you need to refer to your compass direction. You use your north, east, southwest, northwest, southwest, southeast. That is for the general direction. But sometimes the examiner will ask you to give the direction of moving from one place to the other. To say there is teacher X. Teacher X wants to move from her class to the staff room. They will be showing you a map. Give the direction from the classroom to the staff room. So that is where now you need to mention that, okay, from the classroom, teacher X must turn left. So when you give direction, very, very important, always mention the point of departure. To say from the classroom, then you must turn left or you must turn right. And then you continue straight. And then when you give directions, guys, you mention every important landmark that you see. If it's a map of the school, if there are bathrooms, mention that you will see the bathrooms on your left. If there's a tuck shop, mention that you will see a tuck shop on your right. If there's a tap, mention that there's this tap that you will see. If there's a big tree, mention the big tree. And then finally, when you arrive at your destination, you must mention the point of arrival. So most learners are confusing these 2 questions. I said you use the compass direction when they say give the general direction. When they say give the the word the general, then you must know that it is the compass. But if they say a person is going from point A to point B, give them the directions of how to get to that point. Then that is where you explain step by step. And remember, how do you explain? You mention first the point of departure to say from here, they must turn left or they must turn right. You must always mention the directions, guys, that the person must go straight, they must turn left, they must turn right. And then all the landmarks that you see. If you are directing someone from one town to the other, mention the national roads that they will pass. Mention the towns that they're going to pass. All those things for mentioning them, that is how we actually allocate the marks. And then finally, you must mention the point of arrival to say your destination will be on your left, your destination will be on your right. And then when you're working with the map, if they ask you to give the directions, make sure that you mark the selected route. Because most of our maps will be in black and white, you don't really even need a highlighter because your blue pen will do. If they're saying a person is here and then they want the direction to there, so you can just use your blue pen to indicate, okay, this is how a person is going to be traveling up to this point. And then once you've marked it, it becomes easier now for you to explain that what is going on. Rather than if you did not mark it, it's not easy to actually explain what is going on, how to give the directions. For me, this is the easiest question in this section in Mathslit, where you have to give a person directions from one point to the other. And it's normally about 4 or 5 marks, which I believe that all learners must get this 4 or 5 marks because it's 4 or 5 marks for free. You are giving a person directions. Everything is there. You just have to tell us what is going on there. And then, guys, we have different types of maps. Like I mentioned when I started. So this example here, it is a grid reference. A grid reference is called a grid reference map because you work with grids. And then it is grids. This side we've got the numbers. And then this side we've got the alphabets, the letters. So if I wanted to ask you, if I asked you, what is the grid reference for Durban? Here is Durban. So it means the grid reference for Durban would be what? Would be D3. Others will want to say 3D. It's okay, it's fine. But the correct way of saying it is actually D3. That is the grid reference for what? For Durban. And then, guys, when you work with the grid reference, you don't look at the letter, the writing. You look at the point, at the position. For example, the grid reference for Nelspruit. Where is Nelspruit? This is Nelspruit. You see Nelspruit. But the position of Nelspruit is actually here on this dot. So if you were to give the grid reference of Nelspruit, it would be what? It would be D2. It is D, and then it is a 2 there. If we wanted to give a grid reference of the Karoo National Park, where is Karoo National Park? This is Karoo National Park. But where is the position? This is the position of Karoo National Park. So what is the grid reference of Karoo National Park, guys? It is B4. We look at the position, not the writing, not the weight. I hope you guys understand. And then, guys, we also on our map, as you can see, we have a compass direction. So these are the possible questions that you can find in the exams with regards to the compass direction. If they say this is Pretoria, guys, it's in Gauteng, and then this is East London, give the general direction of East London from Pretoria. Give the general direction of East London from Pretoria. When they say from, you know that that place where they are saying from, that is where you are going to position your compass direction. Do you see? Here's our compass. They said from where? From Pretoria. You go and position your compass direction there. That never, ever smoke weed. So it means if you are in Pretoria, where is East London? East London is here. It is in the south of Pretoria. That is how you answer it. I know it's easy, but when it comes to questions, when it comes to interpreting it, people are having problems. If you were in the Northern Cape, this is the Northern Cape, and then they say, give the general direction of Eastern Cape in relation to Northern Cape. In relation to and from, same WhatsApp group. So when they say in relation to Northern Cape, this is where you're going to position your compass, in the Northern Cape. And then you know that you must never, ever smoke weed. So we said in relation to the Northern Cape, what is the direction of the Eastern Cape? There is the Eastern Cape, meaning that the Eastern Cape is actually where? It is southeast. It is the southeast of Northern Cape. Let me do another example. Give the general direction of Botswana from Bloemfontein. The fact that they say from Bloemfontein, it means you position your compass direction where? In Bloemfontein. It is north, it is east, it is south, and it is west. They said from, that is where you position your compass direction. And then where is Botswana? There is Botswana. So what is the general direction of Botswana? It is the northwest of Bloemfontein. Girls and boys, for today, we've come to the end of our lesson. Do join us next week as we continue with the section of maps. I promise you it's going to be a very exciting one. Also taking into consideration, guys, that we are doing the countdown towards our June exams. So please make sure that you join so that you know that you are ready and you are prepared for your paper 2. Guys, please remember to continue observing the COVID-19 protocols. Continue to wash your hands, keep the social distancing, keep your mask on until we meet again. Thank you.